Right, so taking a break from the usual programming, we're gonna have a look at my favorite vacuum cleaner. And right, it does this. And so you could go like, yeah, Daria, you're an idiot, do charge it. To which I'd say, yes, you're right, I am an idiot. Let's charge it. And so yeah, this is basically the status quo of this battery. Fortunately, it's not mine. And so mine works. So it's fine, but let's do actually make this one work as well. 10, let's see if that works. And yes, it does. Jesus, fuck. Please open already. I'm begging you. Okay. Yeah, so, yeah, I don't know, I think it's just clips. Maybe heat staked in or ultrasonically welded in this trench. What do we have? Samsung cells. INR 18650s. You can totally buy some off of Encon NL. And this has a very nice system whereby the vacuum actually pulls a vacuum from here as well and ventilates the pack, which does get pretty hot. I mean, I think it uses about 800 watts, and these are single cells. It is a 1, 2, 3, 4, 5, 6, 7 S1P pack. Yeah, so basically right now what I'm very curious about is how balanced this pack is. Ooh. And nothing super spectacularly out of the ordinary, but rather unbalanced, I will say. Ooh. Nah, really not that tragic. So what I'll do is I'll probably set up a time lapse. I have my lithium ion tester, which will charge all of these up, and just take it from there. So I'll start rebalancing it, and then I'll talk to you guys in, for me, 7 to 50 days. For you, probably less than a minute. All right. All right, so sad news. I've finished rebalancing all the cells. They're best part of 4.2 volts, all of them, and it does exactly the same thing. So if you touch it randomly, it will occasionally blink the red LED. If I connect it to the vacuum cleaner and charge it through this port, it does the same blink. And if I charge it externally through the dock, it does the same thing. So that is probably because the BMS noticed a failure state and has put itself into a kind of a suicide mode, which is, yeah, understandable. I get it. But we now somehow need to reset it. Initially thought this was the chip controlling everything, but this is just a quad op amp from ST, a 324. Then I scratched this up and couldn't find anything on it. And then this looks like it has some power stuff, so it's probably the hardware BMS side of things, right? A dedicated BMS ASIC. And it struck gold over here. And this is a Holtec ARM chip. I don't know if I can make it. Yeah, there you go. And so I do have a data sheet for it over here. It's an M0 core. Bit of an annoying pinout, but yeah, these things do 50 functions per pin. And yeah, I did actually measure it ever so slightly, and I didn't find what I was looking for. But let's see, I'll continue probing at this, and I really want to see if I can do something with this 10 pin, right? So I'll just put my meter in current mode, in amps, probably the higher amps mode, and just touch onto the reset pin. Let's see if that works. I'll be back. Alright, so I'm here on the couch, and I have tried some weird shit with the microamps range, and that is the following, and nothing worked, by the way. So RST pin 10 is actually connected to this tiny jumper here. So bridging this to ground or to the pin neighboring just slightly illuminates this LED. We can actually show this on camera probably. Right, so if you do this, nothing happens. All right. How about the ground? Maybe I fried the fuse on that. Maybe it wants to be in the milliamp range. I don't know. It might be. Let's see. Yeah, so it does this ever so slightly visible faint glow, and does it when you bridge it to ground as well. Right? I don't know if, anyway. So that does nothing. Still doesn't work. And I'll show you how it doesn't work. Same thing. I can't actually try charging it. I will do it later. But anyway, I did try something a bit more extreme even. And so there's a regulator here that supplies 5 volts to the micro. We could actually short that out, and that is what I did, right? For an even more proper reset. And so let's showcase that. Whoop. And so this square pin looks like a power pin, and it is showing 5 volts. So if we just boom, short it out, you can see we get this kind of a reset sequence, and unfortunately that also doesn't work. I wonder if this has any flash. Well, it definitely has flash for the code, so they're probably storing stuff non-volatile, storing some non-volatile information that we are dead, so the suicide persists. Cell swaps, so that is already malicious in my opinion, right? We'll see. I'm still digging at this, but this is exactly what Bose did, right? The BMS controller, IC, whatever it was, I think it was a micro as well, remembered that I am dead throughout power cycles, right? So basically ensuring that the pack is dead. And by that point, right, if someone, the safety argument doesn't really float. We'll see. I'll again keep digging. So we're back on the floor. My head hurts like fucking crazy. I took a shower, and it's like I didn't drink my coffee. I swear to God, I did drink 2 coffees. I'm pretty sure today. I don't know. I'm gonna do another one. But anyway, so I'm in my shower, and I cannot for the life of me start the water because this shit is bugging me. Why isn't it working? Is it actually storing the I am dead flag in non-volatile memory? And I even packed it up, right, like tossed it on top of its case and left this, right, just upload whatever I have and just mention to not let them kill themselves, right? And then I watch, I somehow read this one guy in English, right, at the point of making this video, there's about 3 videos talking about this issue, and they're complete garbage and actually like fixes, right? And there's this guy that takes it apart, puts it back together, and then says it worked miraculously. Like, fuck you, why did you upload this? Like, what? Anyway. So someone else is talking about the problem about these batteries failing, and mentions a German blog, right? A German guy, right? So I quickly Googled some German stuff, didn't find it, and then I find this guy, right? And he basically goes over the issue itself, right? But he does at some point, without linking, which is a very dick move, showed this blog post, right? So I anyway.
Und es gibt auch
And so I start searching, right? I'm in my shower, I'm naked, the water is off, it's insanely uncomfortable, my head is popping. And what am I doing? I'm actually screenshotting this on the phone and copy pasting lines, hoping Google will find it. Google doesn't find it. Super pain in the ass, takes about 10 minutes. I am in misery and my brain is keeping me stuck in the misery. By the way, we're on the floor because, and that's on the floor because my workbench is absolutely full. This is absolutely full. This is still curing, and my workbench, I don't know, I work there, so I don't know, I don't want to, anyway. I find the blog, right? I find it. So it's Thomas here, danke dir. And he says something that I really don't agree with. He says that the cells that are closest to the load are loaded down the most because something, right? Because the resistance is higher as you go through the pack. But dude, doesn't matter how big the resistance is, current should be the same, right? The only thing that could affect these more is perhaps a bit more heat from whatever's on this board or the motor itself being close by. You know, I fear trusting myself indefinitely. So if anyone else knows this theory or if what this guy's talking about, so he says that this one will get fucked the most, but I don't know, man. Shouldn't current be the same throughout the entire circuit? I don't know. Anyway, leave it down in the comments if you have any thoughts on this. And if you made it this far into the video, which is probably like 59 minutes and 5,000 seconds. Anyway, so he does go on about that, but he does put up this picture, right? And he has the, yeah, this kind of does indicate his theory. I didn't, like, did I find the same thing happen, right? So yeah, I guess, right? I guess. So I have the same thing, right? Discharging them. I must have counted one on this side. Did I? I don't remember. We'll check the video. It doesn't matter, but they are in order. But I find it hard to believe that that is the reason, right? That a series string, right? The one closest to the load. And what does close to the load mean? Because these two are closest, right? The ones at the edge. I don't know. There's something messed up with this board, right? They've definitely, if all of ours get unbalanced the same way, then it's a problem, right? And we already have 2 of them. Do we have the same cells? Yeah, we do. But I've seen these with LG cells as well. Anyway, so this isn't particularly mind-blowing. Can we close this? This isn't particularly mind-blowing, but there's another guy, or is it still Thomas? I don't know. But there's someone that gives very nice, yeah, Damian. So Damian, danke dir auch. what can you do, right? If you don't get the red blink of death, we'll call it, because that's what humans do, you could basically rebalance them externally and prolong their life, or even if you fancy or see fit, replace them completely. But if the red LED blinks, then this guy, as well as my past self before seeing this forum, ascertained that they must actually be storing the I am dead state in non-volatile memory. So at that point, you can swap everything out, and the microcontroller will store, this Holtec microcontroller will store inside of it that no, we are dead. So no matter what it sees outside, it will know and remember that it is dead. And that is basically a very dick move from Xiaomi. Like, I'm sorry, I can't for the life of me find any reasonable argument why you do that, right? But anyway, I'm sounding like Louis Rossmann now, and fuck Xiaomi for doing this. And it's not Xiaomi, right? There's someone that's manufacturing these for them. Xiaomi's, I don't know, yeah. Fuck whoever decided that in particular. And with that being said, I think I'm done. Like, this has to be, yeah, I'll probably just reuse these. It'll be a nice test, right? These were worn down, right? And used for 4 years and used hard. Kept always fully charged and then drained with 35 amps, if we believe Thomas there. And we should, right? It's close, right? What is it? Should be about 450 watts divided by 30 volts at most, 15 amps. Yeah, no, I think he's off by a factor 2. Anyway, I don't know. Regardless, it'll be nice to come up to recheck these. Right now they're fully charged as well. I might actually discharge them from the ends to like 40% just to not cook them, just in case I need a 7S1P battery. But it would be nice to see, right, if any of these sag below 3, because I've had this happen, and I actually did have a discussion on my channel with someone. I did have this happen with some cells out of my Pro 2 battery, right? They would charge fine, discharge fine. I left them for 6 months, and then I found them at 2.1 volts, right? So their internal resistance did go up. Right, enough rambling. It's enough for today. Have a good one. Yeah, so as promised, I started up the reactor. This load does work, but it will make this noise absolutely all the time. It's disgusting, but it has some fail-safe resistors in case the MOSFET's bridge closed. Yeah, should be fine. And I've set it to cut out at 24.5, which is roughly 3.5 volts per cell, just to leave it at 40%-ish charge. So yeah, this is gonna cook here for quite a while. That's been it for the update. Bye. Alright, so editing Daria here. I actually am missing some content, believe it or not. And the thing is, I actually did buy another battery. Right, so after trying to fix this one, I acquired one that hadn't yet killed itself, right? And that one I did actually balance and managed to fix, right? So the following content relates to that battery, and yeah, I'll just let my past self continue talking. Alright, so it's now a few days later, and I did actually balance all of these. And there probably is some architecture problem, because these at the close to the connector edge do get a lot more discharge, right? So these are the voltages I found the cells at. So starting with 4.125, 4.05, 3.8, 3.6, 3.5, 3.5, and the lowest over here, Right, so in this one I managed to feed another 1863 milliamps, and you can see it goes down, right? 1800, 1600, 11, 0.8, 0.4, and the last one, can I put this on the table? I don't think I can. Just set it off here. The last one is 53 milliamps, so this one was the fullest. So plus, god damn it, 53 milliamp hours. And this is in August of the current year. So I'll put this back together. I'll need these light guides over here. And I'll probably do another speed run, right, on full power with the GoPro, right? We'll vacuum the house, but I'm actually expecting some guests tonight, so we'll let them prepare the floors for the experiment. And yeah, we'll take it from there. Alright, so the party has existed. We have this kind of a mess over here. I'm not sure if it's visible, but let's get to it. Again, we're using the rejuvenated battery, and it had 365, is it, milliamps, 69 milliamp hours, and it lasted 1 minute on the last run we had. So let's see how we do now. Damn. Well, the angle was pretty shit, I'm sorry. But yeah, that was a good 6 minutes. And this is toasty hot now. Alright, I'll be back with the conclusions. Alright, so to sum everything up, I decided to use this shot. Right, and yeah, so basically you can indeed rebalance these cells. You have to definitely do it before they completely die. Regarding my comments to Xiaomi, I still don't have a clear opinion. On the one hand, I can understand how they don't want these to sit in a cupboard for 10 years, completely die, and then accept a charge. But then again, that's not really an issue, because once you would connect the pack to power, you could detect that all the cells are zero and just refuse to charge them, right? So the reason for completely nuking the battery pack still seems somewhat devious and somewhat, I don't know, it's a bit of a sour taste in my mouth. But now I do have a spare battery, at least. I don't know what else I'll do with it. I listed it online for about like 40 euros, 50. They're about 60, I don't know how much. But yeah, that's been it. I hope you found this helpful, or at least entertaining. And if you have any questions, leave them down in the comments. And I'll see you next time.